We're at the bottom of the Kaibab Limestone Formation. And look at these lines that are laid down. It's fairly weathered, but you can still see lines. You can see what's called lamina. Lamina is really those fine lines that are laid down. Now, the prevalent school of thought is that it took a long time to lay down each one of these lines or these layers. That, who knows, thousands of years, hundreds of years, but a long time. But when we look at erosion, even on construction sites, we see that that does not have to be the case. We have a picture we took at a construction site where you see 3 feet of sediment laid down, and you can see the detail of the lamina, the lines there. But that only happened over a period of 2 months. In fact, you can see that it was then later eroded, and actually looks like a little mini Grand Canyon itself. These sediment layers can be laid down very quickly. It does not have to take a long time. So the other thing I want to point out right here that's really important when it comes to erosion theory is where we're standing. I am standing, my feet are on the Toroweap Formation. Right here, I'm touching the Kaibab Formation, the Kaibab Limestone Formation. The distinction, the line that separates these two formations is incredibly flat. It is amazingly flat. In fact, come back here just behind me a little bit, we'll take a look at the actual place where it transitions. Right here, you can see it exposed a little bit. Right in here, notice this Kaibab, Toroweap, but a flat line. In fact, if we look down, we see that it just extends on and on and on. In fact, if you look across the canyon, you'll see the same line over there. In fact, the Kaibab limestone is known as the bathtub ring of the canyon because it's the white ring that circles the canyon. The common assumption is that each of these layers are separated by long periods of time, but erosion principles would indicate otherwise. If there were long periods of time between the laying down of each sediment formation, we wouldn't expect to find such a uniform, uninterrupted linear transition. Smooth, compact, erodible surfaces do not tend to stay that way when exposed to weather, so we would expect to see signs of weathering, channels, depressions, and elevated points, especially in the slope-forming layers like the Bright Angel Shale. The area around the Grand Canyon is another great example. The surface, you will notice, is no longer flat. It has signs of water erosion and plant erosion, and you will note that there are paths of preferential flow, which are now gullies and ravines. Now contrast this surface topography with the linear transitions that we see between the Grand Canyon layers. So as an erosion professional, I look at this and go, wow, I think this was laid down almost immediately after the Toroweap layer was laid down. In fact, we see that same progression, that same thing happening between each of the layers as we go down to basically the great unconformity in the canyon. So amazing play out of erosion theory right here. Okay, let's head on back up to the top. Let's get a drink of water, and we're going to talk about the R value in the Russell equation and talk about erosivity and what climate has to do with it and the energy of the storms.